A concrete test is a method used to check the quality, strength, and workability of concrete before, during, or after construction. It ensures that the concrete mix meets the required structural and durability standards. Purpose of concrete test: to check compressive strength, to check workability, to ensure durability and proper curing, and to maintain consistency of concrete mix. Common types of concrete tests: slump test, which measures the workability of fresh concrete and ensures it can be easily placed. Compressive strength test measures the strength of hardened concrete using cubes or cylinders, usually tested at 7, 14, or 28 days. Other tests include the split tensile test, flexural test, rebound hammer test, and core test.
The slump test is a simple field test used to measure the workability or consistency of fresh concrete before it sets. It indicates how easily concrete can flow and be compacted without segregation. To check workability of concrete, ensures concrete can fill the formwork properly. Detects if the concrete mix is too dry or too wet. Slump cone, base plate, tamping rod, measuring scale. Place the cone on the base plate. Fill the cone with fresh concrete in 3 layers. Tamp each layer 25 times with the rod. Remove excess concrete from the top and lift the cone vertically. Measure the vertical slump. True slump, concrete subsides evenly. Shear slump, top part slides sideways. Collapsed slump, concrete collapses completely. Low slump, stiff concrete, less workable. Medium slump, normal workability. High slump, very workable or wet mix.
The compressive strength test is a laboratory test used to determine the ability of concrete to withstand axial loads. It is one of the most important tests for structural concrete because concrete is primarily strong in compression. The purpose is to check if concrete meets the design strength, ensuring structural safety and durability, and helping in quality control during construction. Concrete is cast into cubes, cylinders, or prisms, with standard sizes like 150 by 150 by 150 millimeters cubes, or 150 millimeters diameter by 300 millimeters height cylinders. The procedure involves casting and curing the specimen, placing it in a compression testing machine, applying gradual load until failure, and recording the maximum load. Standard testing ages are 7 days, reaching approximately 70% of design strength, and 28 days for full design strength, which is the most common standard. Remember, concrete is strong in compression but weak in tension, and proper curing and compaction significantly affect the results.
The split tensile test is a laboratory test used to determine the tensile strength of concrete. Since concrete is weak in tension, this test helps evaluate its resistance to cracking. The primary purposes of the split tensile test are to measure the tensile strength of concrete and to study crack resistance. It's also used for quality control and mix design evaluation. The procedure involves curing the concrete cylinder for 7, 14, or 28 days, then placing it horizontally between the platens of a testing machine. A continuous compressive load is applied until the cylinder splits vertically due to tensile stress. Failure occurs due to tensile stress, not compression, and tensile strength is approximately 8 to 12% of compressive strength. This test is also easier to perform than a direct tensile test, making it a crucial method for assessing concrete structural integrity.
The flexural test is a laboratory test used to determine the flexural strength of concrete. It measures the ability of concrete to resist bending or tensile stresses that occur when a beam is loaded. This test is important for pavements, slabs, roads, and beams, indicating how concrete behaves under tensile stress and bending.
The rebound hammer test is a non-destructive test, or NDT, used to assess the surface hardness and approximate compressive strength of hardened concrete without damaging the structure. Its purpose is to estimate in situ compressive strength of concrete, check uniformity and quality, and identify weak or deteriorated areas. The key equipment for this test is the Schmidt rebound hammer, which uses a spring-controlled mass. The procedure involves cleaning and smoothing the concrete surface, then holding the hammer perpendicular to the test surface. Press the hammer until it impacts the surface. Note the rebound number shown on the scale. and take multiple readings to calculate the average. Higher rebound numbers indicate harder concrete and higher strength, while lower numbers suggest softer or weaker concrete. Calibration charts are then used to estimate the compressive strength. The advantages include no damage to the structure, quick and easy on-site performance, and usefulness for existing buildings. However, limitations exist. It measures only surface hardness, not core strength, and is affected by surface moisture, roughness, carbonation, and age. The results are approximate, not exact. Applications include quality control on site, checking the strength of old structures, and selecting locations for core testing.
Destructive core test determines strength and quality of hardened concrete and structures. It measures compressive strength, detects defects like voids, verifies strength for doubtful tests. It leaves holes, requires skill, provides accurate strength data for old buildings and repairs.